Look at this question. There is a lot of calculation is involved, but for the time being I don't want to show the multiplication and division. Just 1 minute. So here the photoelectric threshold frequency we are familiar, clear? Threshold wavelength means it is a minimum wavelength. Sorry, it is the maximum wavelength, not minimum. It is the maximum wavelength of the radiation for emission of the electron. Okay. So lambda 0. Okay, lambda 0 is the threshold wavelength. Lambda 0. We know that lambda 0 is equal to c by mu 0. Clear?
Yes, sir.
We know that. Okay, it's required. That's why I have written in the beginning. Threshold wavelength is the cutoff wavelength. Okay, for emission of the photoelectrons. But normally I want okay, lambda 0 equal to c by mu 0. You know the reason. Okay. The velocity of the electron ejected from the silver surface by ultraviolet light of wavelength this. Velocity we have to find out. You know that the kinetic energy is half mv square, correct?
Yes, sir.
Half mv square equal to h mu minus phi 0, correct?
Okay.
Okay, in the okay, so half mv square is equal to h into mu. Mu is not given. Mu is the
C
frequency.
by
Yes, c by lambda. Mu is c by lambda. And phi 0 I have explained in the previous classes that phi 0 is equal to, what is phi 0?
H
H
mu
mu
naught.
0. H mu 0 becomes hc by lambda 0. Okay.
Yes, sir.
Okay, because phi 0 is not given in this question, so we studied in the earlier that phi 0 equal to h mu 0 or h into c by lambda, hc by lambda 0.
Okay, sir.
Okay, we get this equation. So uh, okay, we can substitute. There is a lot of calculation is there, but I don't want to discuss. After the class you can check the multiplication division. Okay,
Okay,
so
sir.
v square is equal to, they are asking for the approximate value. So wherever you can reduce the simplify, you can do it. Okay, maximum simplification approximation you have to use. Half m go to right hand side, you will get 2 by m. Okay, clear?
Okay, sir.
Half m becomes 2 by m in the right side, and hc is common. Okay, clear?
Yes,
Hc
sir.
is common,
Uh,
or you can keep hc there, no problem. You can decide hc is common into 1 by lambda minus 1 by lambda 0. Okay, clear?
okay, sir.
Then you can make the substitution 2 by m. M is the mass of the electron. You know that what is the mass of the electron? You know that?
9.1 into 10
Yeah,
power minus 31.
10 raised to minus 31. H is 6.63 into 10 raised to minus 34. C is 3 into 10 raised to 8 into 1 by lambda. Okay, let me write here, there is no space. So you do after the class, you please do 9.1, you have to take as 9, no problem at all. Okay, clear?
Okay, sir.
If possible 6.63, 6.6 itself to be multiplied with 3, and if you are able to remove the decimal after point, just to remove it. The
Okay, sir.
options are, they are asking for the approximate value. Okay, they are asking for the approximate value. 1 by lambda, 1 by lambda, wavelength of the radiation is given. It is 2536 into 10 raised to minus 10 minus 1 by lambda 0. It is also given 3250 into 10 raised to minus 10. Okay, clear? So after the class, you please try the simplification part. Okay. Or
Yes.
maximum approximation you have to apply. Then definitely you will get the answer. Okay. Okay. Understood.
Yes, sir.
So let me write the answer for the time being. Approximately you will get 6 into 10 raised to, sorry, 5 meter per second after taking square root. After that you have to take the square root. So please do it as the remaining steps as homework. If you are not getting, please send the message. Okay.
Yes, sir.
So the approximate value is this. Option D is the correct answer. Okay. Method is clear. Understood?
Yes, sir.
Uh,
Understood.